Hello, and thanks for tuning in for another ramble. Today we're looking at question 9b of IEB's paper 1 from November 2022. Right, on the set of axes below, sketch g of x is equal to log base 2 of x if x is smaller than or equal to 4. Okay, so the domain is restricted even more than usual. Yeah, I won't lie, I don't really know how to draw log graphs. I always have to think about how to draw the exponential, the inverse graph, and then from there I just reflect it in the y is equal to x line. So y is equal to log base 2 of x. The inverse of that is y is equal to 2 to the power of x. Right, so that graph, I'm very comfortable to say, looks like that. Oh no, it would cross the y axis at 1. Yeah, because if I put a 0 in here, I end up with 2 to the 0, which is 1. Okay, I'm not drawing this well at all. Because there's a grid, I can't just freestyle. I actually need to be a bit more accurate. So there's that point. And 2 to the power of 1 is 2, and 2 to the power of 2 is 4, and 2 to the power of 3, well, that can't fit. And then here we're going to have a half, a quarter. Okay, here I can be a bit more reckless. Right, so something like that. So then the inverse, the log graph, is going to be the reflection in this line, y is equal to x. Okay. So now we'll have an x-intercept over here, right? Because when you reflect in the y is equal to x, the each point on here, the x and y coordinates get flipped around. So now instead of having 1, 0, 1, we're going to have 1, 0. Instead of having 1, 2, we're going to have 2, 1. Instead of having 2, 4, we'll have 4, 2. And the domain ends here, right? Because x has to be, did I say greater than in the beginning? It has to be smaller than or equal to 4. So we're not going further than this. Okay, and then let's see what's going on here. So here we'll have, instead of negative 1.5, we'll have half and negative 1. And then we'll have a quarter and negative 2. And so it's going to go this way. Right, something like that. Okay, definitely do a better job than me, guys. Come on. Right, and don't go further than the 4. Okay, yeah, something like that. Okay, so that will be the graph of G. Okay, and this over here is the graph of the inverse of G. Okay, right. So that's that on that. I don't know if I'm meant to label the intercepts, but we will. That's for good measure. On the set of axes above, sketch the graph of the inverse. Right, write down the domain of the inverse. Okay, so also interesting, we have to think about this limitation here. This doesn't just go off to infinity and beyond. So the restriction here was that x has to be smaller than or equal to 4. So for the inverse graph, what that means is that y can't go beyond 4. So I need to get rid of rho. Yeah, I'll write the label again just now. Okay, right. So that would be very important. Okay, so what is the domain? The domain is x is anything smaller than or equal to 2, right? Because that is 2 is the one that gives us our last point, at least in the positive direction, the positive x direction, right? And then the last question. Oh, golly, the last question, just trying to erase stuff before we get there, is up here. For what values of x is hot. So for what values of x is g, so inverse of g times first derivative of g divided by g of x smaller than or equal to 0. She's a Louise. Oh, give me back pain. Oh. Okay, so for it to be smaller than or equal to 0, well, so we have broadly the top being positive or greater than or equal to 0, and the bottom being negative, or the top being negative and the bottom being greater than 0, being positive. Okay, and then for this one, when is it greater than or equal to 0? So the important thing to recognize here is that this is always positive. It is always positive. So in order for this product to be greater than or equal to 0, then we need this to be positive as well. Positive or equal to 0, and I don't think we ever get the gradient being equal to 0. Yeah, because we don't have a turning point on the exponential graph. So, right, let us deal with case number 1. Ooh. Little n is gone. Yeah, guys, what's going on? Okay, just gonna move that down a little bit. Okay, so g inverse of g is greater than 0 for for all x. Don't even care about the restriction on the domain, like it is always going to be positive, right? So then in order for this product to be greater than or equal to 0, well, the other thing is that, yeah, this is also never negative, because our exponential is just, it's always increasing. It's increasing for all values of x. So, and g prime x, so let me say this, and g of x is increasing for all x in the domain as well, in the larger domain. So therefore g prime x is greater than 0 for all x greater, all x in the domain, right? So therefore inverse of g times g prime x is always positive. Okay, so we don't even need to consider the second case where we're looking at where it's negative, because that's just not going to happen, right? So really what we care about is where is g of x negative, right? Because then that is what will make this inequality true, and it is negative over here, right? For this part of the graph, g is producing negative values, and that is happening when x, the input, is between 0 and 1, right? So g of x is negative when x is between 0 and 1, and then of course we have to think about, okay, are we including our boundaries or not? So when x is equal to 0, the function is not defined, so we're not going to include 0. And then when x is equal to 1, the function is equal to 0, and we don't want g of x to be equal to 0, we want it to be strictly negative, so we can't include the 1. Right, so as a result, what we are saying is this is always positive. This product is always positive. The inverse of g always produces positive results. The gradient of g, oh hectic, the gradient of g, I was looking at the gradient of the inverse, oops, sorry, but the same logic applies. It is increasing all the way. There's no point where this graph decreases. So by the same logic as we said, g is increasing all the way, so that means g prime is also then going to be greater than 0 for all x in the domain and beyond, for all real numbers. So then what we care about is where this denominator is negative, and that is happening when x is between 0 and 1, but not including the boundaries. So this product divided by this guy is going to be negative or equal to 0. Well, it will never be equal to 0. Why would it ever be equal to 0? It won't be equal to 0 because neither of these can be equal to 0. Right. I'm not going to explain again why. So it's happening here. Right. Memo, what do you think? Memo. Right, our graphs are looking good and in sync. Sorry, burp. And then the domain, we agree x is anything from negative infinity to 2. That is for the inverse function. And then we have this inequality only being true when x is between 0 and 1. Cool stuff. I hope that you enjoyed that. I think that was pretty cool. I liked that. The memo, I don't know, I'm not really understanding the solution for the last question, but we arrive at the same thing, so I'm gonna leave it at that.